Let's look at characteristic of a ring. So the definition is the smallest number n belonging to the set of natural numbers such that for all r belonging to the ring n dot r, which can be written as r plus r plus r so on n times is equal to 0 is called the characteristic of the ring R. So it may look funny initially that you are taking a natural number and you're multiplying it with a element of a ring and you are getting 0. This doesn't happen with respect to our commonly used number systems. So characteristic of integers is going to be 0, because if we take a number and add it to itself whatever number of times, we will never get back to 0, or we will never get to 0. Similarly, character of rational numbers is equal to 0, because there is no n, there is no smallest n where this becomes 0. We say it is similarly characteristic of real numbers is equal to 0. Similarly, characteristic of complex numbers is equal to 0. Similarly, characteristic of polynomials with coefficients, integer coefficients, is equal to 0. So when no such n is present, characteristic of the ring is 0. Okay, but there must be some number system where it will be 0, right? So let's look at our modulo arithmetic modular arithmetic. So here, for all a belonging to Zn, right, this can be also written as Z by Z nz. Now here what happens, if you take an element and keep adding it to itself a certain number of times, you will get back to 0, right? So this is n times. Let's say if we add it up n times, we will get, it can be written as n times a, we will get to 0, which belongs to the set of integers. So therefore in this case, characteristic of Zn is equal to n. Strictly speaking, we can't say n because there could be some other number also which could satisfy this condition. So let's say character of Zn is some number less than or equal to n. If we can show the other way around, then we can say it is equal. Okay, if we can show that n is less than or equal to character of Zn. Okay, so to prove that, let m be the character of Zn, which implies that m is equal to 1 plus 1 plus 1 plus, because additive identity always exists. So if we take 1 and keep adding it to itself m number of times, we should get to 0, which belongs to Zn, right? Now in modular arithmetic, we write it as m is congruent to 0 mod n. But remember, this implies that n divides m. Now if n divides m, it means what? N is less than or equal to m, right? So since n is less than or equal to m, let me write it fully. Character of Zn is less than or equal to n. which is less than or equal to m, implies that character of Zn less than or equal to n. There are other numbers which will add up to 0, but they will always be greater than n, because m should be divisible by n. Okay, now let's look at another a different way of looking at it. Let R be a ring with multiplicative item and n belongs to the set of natural numbers is the least number such that n times 1 is equal to 1 plus 1 plus 1 times plus 1. How many times? N times is equal to 0. Then characteristic of R is equal to n. So here the difference between the definition and this is, here we were taking any element of R, whereas here we are taking 1 itself and adding it to itself. Okay, so what this leads to is, let R belong to the ring, some arbitrary number, then n times R is equal to R plus R plus R plus R n times, which can be written as R is common, so we can take it out, 1 plus 1 plus so on plus 1 n times. But we have already seen that 1 plus 1 plus 1 equal to 0. So which means R times 0, which means 0, right? Which belongs to, okay. Now let's look at an example. Let's say Z6, Z mod 6. Now this is 0, 1, 2, 3, 4, 5. And here what we do is, if we add 0 6 times, we will get 0, right? Which is trivial. So let's starting with 1. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5, 5 plus 1 is 6. But remember, we just don't keep adding it. We also take the mod 6. So 1 plus 1, 2, 2 mod 6 is 2, 3 mod 6 is 3, 4 mod 6 is 4, 5 mod 6 is 5, 6 mod 6 is 0. So this is equal to 6, which is congruent to 0 mod. Similarly, 2 plus 2 plus 2 plus 2 plus 2 plus 2 is equal to what? 6 times 2 is 12, which is again congruent to 0 mod 6. 3 plus 3 plus 3 plus 3 plus 3 plus 3. 3, 6, 18, which is again congruent to 0 mod 6. Now, instead of writing it 6 times, what I can do is I can say 6 times 4 is equal to 24, which is again congruent to 0 mod 6. 6 times 5 is 30, which is again congruent to 0 mod 6. So therefore, characteristic of Z mod 6 is equal to what? Is 6. This might give you a wrong impression that characteristic of Zn is equal to n, because here it is 6 and here it is 6. But that's not true. So let's take one more example to understand this. So let's take Z12, right? Rather 3Z12, which gives us 0, 3, 6 and 9, right? Now what will be the characteristic of this? 0, it doesn't matter how many times we do it, so that doesn't give us much. Let's take 3. 3 plus 3 is 6. 6 mod 12 is 6, right? Let's add one more. 9 mod 12 is 9. So it is not 0. Plus 3. So now we have 12 mod 12, which is equal to 0. Or rather, I should write it as is equal to 12, which is congruent to 0 mod 12. Let's verify it. 6 plus 6 plus 6 plus 6. 6 fours 24, which is again 0 mod 12. 9 plus 9 plus 9 plus 9. 9 fours 36, which is again 0 mod 12. So here, in this case, characteristic of Z12 is equal to 4. So be careful when you are trying to figure out the characteristic. Don't think in these terms. Okay, now jumping a little bit slightly ahead, uh, let's look at another interesting aspect. If R is an integral domain, we will look at this integral domain later on, but this is very interesting, that's why I'm including it here. Then the characteristic of the ring R is a prime number, or the characteristic of R is equal to 0. So either it will be a prime number or it will be 0. So here, let's very briefly look at what is an integral domain. So integral domain is a commutative ring. That means, see, when we say commutative ring, we are talking commutativity with respect to multiplication. Because commutative addition is automatically a part of the ring definition. So it is commutative, a commutative ring. Second thing is has a unit element, has at least two elements, and no zero divisors. So no zero divisors means what a zero divisor is, we have already seen, but let me very quickly review it. If we have A times B is equal to 0, no zero divisors means that either A is equal to 0 or B is equal to 0. Whereas if we say there is a zero divisor, let me briefly mention that A times B equal to 0 implies A is not equal to 0 and B is not equal to 0. If that is the case, then we say that A and B are zero divisors. No zero divisors means this, right? This is the normal thing that we have been using throughout our high school and all that. Okay, so now how do we prove this? What we'll do is we will use this concept of zero divisors, and we will say if characteristic of R is equal to n, then R is not an integral domain. We will start off by assuming this. And here we are assuming that Rn is a composite. That means it is not a prime number. R is an integral domain, then characteristic is a prime number. So here we are saying it is not a prime number, so R is not an integral domain. So let's see how we can show this. So n is equal to characteristic of R where n is equal to A times B. Because we are saying it is composite, no? So let's make it as a product of two elements. And here A and B both are, let's say, greater than 1. So as per the definition of the characteristic, n times 1 is equal to 1 plus 1 plus 1 up to n times equal to 0, right? Or we can say n times 1 is equal to, now let's replace n with A times B. So AB times 1 is equal to 0, right? We have just replaced this n with AB because we said n is a composite number. Now, this can be written as A times 1 and times B times 1 equal to 0. Right? Now, we know A and B are both greater than 1, and we know n is a product of two numbers. Now, if it is a product of two numbers, we know n or A is going to be less than n and B is going to be less than n, because n is the product of these two numbers. Okay. So since it is greater than 1 and since they are less than n, implies that A times 1 is not equal to 0. Because if it was n, it would have become 0. Right? But here it is less than n, both A and B. So A times 1 is not equal to 0 and B times 1 is not equal to 0. So what we have is A times 1 times B times 1 is equal to 0, but A times 1 is not equal to 0 and B times 1 is not equal to 0, which means what? That A times 1 and B times 1 are the zero divisors, right? So since zero divisors are there, that means what? The characteristic of R cannot be a prime number, which is what we started off by assuming, that it is a composite. So if it is composite, zero divisors are present. So that way we have shown that if R is an integral domain, then characteristic of R is a prime number, or it can be 0. I think that's enough. Bye.